In this video, we're going to be looking at linear transformations and shapes of data. So let's start with the first part, which is linear transformations. So we've been doing transformations of functions quite a bit. With transformation of functions, essentially what we've been doing is we've been shifting the data. So what happens if you add something to everything? What happens if you subtract it? We've also been looking at what happens when you multiply. Well, we're going to be looking at the same thing. Just instead of looking at functions, we're going to be looking at sets of data. So the linear transformations here is when we're going to take the same constant and we're going to add or we're going to multiply each data value. So let's see what happens if we add something to the data set. So let's imagine that the data set was 10, 10, 11, 12, and 13. First of all, to help us figure out what's going to happen, let's calculate the mean, the median, the mode, and the range. So the mean would be that we add them all up. So 10, 20, 31, 43, and that's going to be 43 plus 13, so that's going to be 56. So here we have 56 divided by 1, 2, 3, 4, 5 values. Which is 11.2. The median value would be the middle number. So let's see, the middle number here would be 11. The mode, well, we haven't really talked much about the mode. The mode is the value that shows up the most often. So the value that shows up here the most often would be 10. And the range is when you take the highest, which is 13, and you subtract the lowest, which means you have a range of 3. Okay, so now what we're going to do is we're going to see what happens if we add 10 to every data value. Okay, I'm going to change my color here so that I have a different color. So my new data set would become 20, 20, 21, 22, and 23. Okay, so let's figure out the mean. So let's see, 20, 40, 61, 83, 83 plus 23 would be 106. So 106 divided by, let's see, 1, 2, 3, 4, 5 will give us 21.2. Now if you notice the relationship between the original, which is 11.2, and the new, the average actually goes up 10. So the mean goes up 10. Now your median value will be the value in the middle. So the value in the middle here would be 21. So if the original was 11 and became 21, then the median also goes up 10. The mode was the value that shows up the most often. So if you look at the new set of data, the number that shows up the most often is 20. And again, that goes up by 10. Now if we take a look at the range would be 23 minus 20, which is 3. Interesting, the range stays the same. So here's what this means. Anytime you add or subtract to the set of data, then basically what's going to happen if you add something to the data, then the mean, median, mode all will go up that amount. If you subtract from the data set, the mean, the median, and the mode will all go down by that amount. However, the range is going to stay the same. If you think about the range being the highest minus the least, if both of those numbers are shifted the same amount, whether you're shifting higher or lower, it shouldn't matter. Your range is going to stay the same. Now let's see what happens when we multiply. So we're going to take the same data set. So let's copy over the 11.2, the 11, the 10, and the 3. The median value we said was 11. The mode we said was 10, and the range was 3. So now we're going to see what happens to the data set when we double everything. Okay, double 10 you get 20, double 10 you get 20, double 11 you get 22, double 12 you get 24, and double the 13 and you will get 26. Okay. To find the mean, we're going to add all the numbers up. So I think let's see, I'll do 20, 40, 60, 80, 100, and now I'm going to add the ones places. So 4 and 6 is a 10, so now we're at 110. 110 plus 2 more, that's 112. So we're going to do 112 divided by 5, and that's going to give me 22.4. So if the original mean was 11.2 and we doubled everything, we get 22.4, which means the mean doubles. Let's see what happens to the median. So the median value in the original set was 11 and now becomes 22. So the median also doubles. The mode value, the one that shows up most often, in the original was 10, and in the new data set it's 20. So it goes from 10 to 20, so it also doubles. And the range goes from 26. So we did, let's see, the original range was 13 minus 10, so now it's going to be 26 minus 20. Aha, this one is different. This one comes out to be 6. This also doubles. So unlike adding or subtracting, which keeps the range the same, if you multiply, the same is going to happen with the range. It's also going to be multiplied. Okay, so bottom line, if you add or subtract a value to each data set, the mean, the median, the mode, and the range will, well, the mean, the median, the mode will, all three of those will go up or down by that amount, but the range will stay the same. If you multiply a data set by the same value, or even if you cut a data set in half, it's going to, the mean, the median, the mode, and the range, all of them will multiply by that amount. Okay, so enough on your transformations. That's all we need to know for that. Let's move on to skewing the data set. Oh, actually, let's do a practice question first. So the average score in our last quiz was 75. Ooh, not good. Not good. Mrs. Zagrossi is in a generous mood and decides to curve all the scores by adding 10 points to each quiz. Nice, right? What will be the new class average? Well, we're adding 10 points to everything. So basically, your average score, which was 75, will also go up by 10. If everybody's score goes up by 10, the class average is going to go up by 10. So the new class average is going to be 85. So it will also go up 10 points, as well as the mean, the mean, the median, and the mode will all go up by 10 points. The range, however, will stay the same. So let's do another practice question. So here we have the median of this data set is 11, and I'm glad I gave you the median value because in order to get the median value here, we would have had to have put all of these in numerical order. And boy, that would have taken a long time. Okay, so if I subtract 4 from each data value, what will be the new median of the transformed data? So I want to know what happens to the median if I subtract 4 from every value. Well, the same thing's going to happen. I'm going to do 11 minus 4, and that's going to give me 7. So 7 will be the new median. So basically what's going to happen is everything's going to go down by 4. So your mean, your median, your mode will all go down 4. The range, however, on this will stay the same. Now we're going to talk about shapes and data distribution. We have a couple a couple images here that I want you to take a look at. So what we have here is we've got some histograms, and if we essentially draw right along the top, we end up with the shape of the data. If you look at this data set, we see that this data set is skewed. It actually looks like the data is being pulled down. Now, the best way for me to describe this would be if I took all of your last quiz averages. So I took all your quiz grades and I put them in the grade book. However, I had a student who didn't take the quiz. So I put a 0 in. Well, what's going to happen to, say, our class average if I put in the 0? Well, it's going to bring everybody's average down. So it's going to bring the class average down. It's going to do what we call skewing the data. And it pulls it in a direction. So here we may have some extreme values as part of the data set. Doesn't fit with all the other values. Look at most of the values are between 220 and 370. But we've got these values that are really low down here. And what that does is it pulls the data set lower. So it skews the data, and we say it skews it to the left. I know you're going to look at this and want to say that it's skewed to the right because the bulk of the data is on the right-hand side, but skewing the data means we're pulling the data, either we're pulling it down or we're pulling it higher. And this image is pulling it down, so this is skewing to the left. It's always the direction of what we call the tail. Okay, so this is skewed left. This would be skewed to the right. So most of the data is right here between around 3 to 15. Most of the data is there. But we've got these extreme values that go all the way up to 29 that don't seem to fit with most of the data. This is pulling, say, our average higher. Okay. Now, there's something that you need to know. If we have these extreme values that are pulling the data lower or pulling the data higher, you never want to use the mean to describe the data. So if your data set is skewed, you will want to use the median to describe the data. We almost never use the mode. We rarely use the mode, but so what we're going to do is we're going to use the median. So anytime you have some extreme values in your data set, you got to use the median to describe the data. Perfect example. All right. Let's say we have a company, and forgive my messy handwriting, but let's say we have a company and we have 5 employees. You've got the CEO of the company who is making $350,000. You have an assistant who's making $60,000. You have a manager who's making $60,000, and then you have a couple workers that are each making $30,000. Okay. So I calculated out the mean would be $110,000, the median would be $60,000, and the mode, which we rarely use, is $30,000. If I wanted to accurately describe the data set here, you have to be careful. I could make an advertisement and be mathematically correct that says, "Come work for our company. The average employee makes $110,000." Well, does the average employee make $110,000? If you look at these values here, what people are making, no, only one person is making above $100,000. Everyone else is making less than $100,000. So even though mathematically the mean is $110,000, most of the employees don't make over $100,000. So you have to be very careful. The data set has been skewed. The data set has been skewed by the CEO's amount. So what that has done is it's actually pulled the average up, pulled it higher. So mathematically, yes, the average is $110,000. But in reality, if you want to come work for this company, you got to use a better measure of central tendency to describe what you're probably going to make. The median value is 60,000, so that's a little bit closer to what you would make. Now, given this example, you might be able to start to see how in real life statistics are used all the time and they can be very misleading. So this is one area where the data can be misleading. and you have to be careful. So now let's take a look at something that would be symmetric. Okay, so now these if you have a shape that looks something like this or something like this, we're going to say that these are symmetric. This is also another image. Here we have a dot plot here, and this is symmetric. So if you have data that's symmetric, what you're going to find is that your average will be somewhere right down the middle. So your mean would be somewhere in the middle, and your median would also be very close to the middle. So technically speaking, you could use either, but you could certainly use the mean to describe the data here. The mean and your median will be very, very close when the data is symmetric. The thing that you have to remember is that if the data set is skewed, you have to use the median. So let's practice. So we're going to identify if it's skewed or symmetric. So this is going to be skewed. This is actually skewed to the right. So if I wanted to know what the best measure of central tendency is, these slightly more extreme values here at 6 actually pulls the average higher. So you want to use the median. This data set is skewed left. So these extreme low values are actually pulling the mean down. So you don't want to use the mean, you want to use the median. So here we have a box and whisker plot. Look at how long this tail is. This data set is actually skewed. It's skewed going the direction of the tail. So this would be skewed to the right. Okay, we've got these extreme values, which would be, these would be low values. So that means your average is going to be pulled down. So what you want to use is the median. Actually, and let me rephrase that. These values are high. We're following a number line here. So the extreme values are high, pulling the mean up. I said low, it's up. It's moving the mean higher. Here we have symmetrical data. So you're fine to use the mean to measure the data. That's a good measure of central tendency. So this data here would be skewed. This would be skewed right. And if I asked you what measure of central tendency, because of these higher values here, basically it's pulling the average higher. So you don't want to use that, you want to use the median. This one is skewed left. And when it's skewed, you always want to use the median. Okay, so if symmetric, use the mean. If skewed, use the median. And got to pay attention to the tail. This is skewed left. And this would be skewed right. All right, I'd like you to do a little practice on this and see how you do. Good luck.